The distance formula is a formula that we can use to determine the length of a line segment that connects two ordered pairs. So if we have an ordered pair situated at x1, y1, which is a general representation for an arbitrary ordered pair, and x2, y2, another arbitrary ordered pair, the distance formula is going to give us the length of the line segment that connects these 2 points. So for the derivation, we're going to first of all recall the Pythagorean theorem. The Pythagorean theorem is applicable when we have a right triangle or a triangle with 190-degree angle in it. And if we have a right triangle, then the sum of the legs squared and added together is going to be equal to the sum of the hypotenuse side. So let's take a look at a specific set of ordered pairs, and then we're going to come up with a process to get our distance between these ordered pairs, and then we'll use this process and generalize it to determine the distance formula. So I'm just going to, at random, select a couple of ordered pairs, 1, 1, and 4, 5. And we're going to figure out what the length of this line segment should be. And in order to do that, we'll create a right triangle such that our hypotenuse side is the length of that line segment. Now, if we had specific values like the 1, 1 and the 4, 5, we could determine the length of this leg simply by counting values, like to say, well, we're just going to count 1, 2, 3 units over to get to the value 4. However, if we didn't know what those ordered pairs were, we would have to do something else to get the length of that side. And what we're going to do is take the x value of the second ordered pair and subtract the x value of the first ordered pair, right? We're going to take this distance all the way out to 4, and then we're going to subtract this negative space distance, which was the first x value. So all the way out to 4 minus this negative space gives us the remaining value, which is the length of that leg. And we're going to do something similar for the other leg. Let's say that in order to determine the length of this side, we're going to take the y value, in this case is 5, and we're going to subtract the first y value, which is 1. And that's going to give me the length of the vertical leg. So 5 is the distance all the way to the x-axis, and 1 is this little negative space distance. So if we subtract the 1 from it, then we're getting the length of the leg that remains. So now that we have the length of the legs, we can use the Pythagorean theorem to determine the length of the hypotenuse side. So we'll say d squared is equal to 3 squared plus 4 squared. So the distance squared is equal to 9 plus 16. Distance squared is equal to 25. And then when I take the square root of both sides, generally speaking, if I take the square root of both sides, I have to consider the plus or minus. But because of the fact I'm looking at the length of the side of a triangle, I'm only going to take that positive solution. So the length of that hypotenuse side, or the distance between those 2 points, is 5 units. So now let's generalize that process. And by that, I mean to remove the specific numbers and input x values and y values that are generalized. Nothing specific here. So we'll say then now we're after the distance or the length of the line segment that connects those 2 points. And in order to determine this distance, we're going to create a right triangle again, and one where the hypotenuse side is the line segment whose distance we're after. And now in order to determine the length of these legs, again, what we're going to have to do is say the second x value minus the first x value. So that's x2 minus x1 is the length of that horizontal leg. And the length of the vertical leg is going to be y2 minus y1, and that's how we'll get that part. And then we'll use the Pythagorean theorem now to say that the length of our line segment quantity squared, or the length of the hypotenuse side squared, is going to be this leg squared plus the length of the other leg squared, and now we take the square root of both sides to solve for that distance. Now again, we'll consider the plus or the minus, but we're going to throw out the negative possibility because of the fact that we're looking at the length of a side of a triangle, and we're only going to consider that positive value. And this is then the distance formula that we saw at the beginning of this video.